You know that feeling? You're staring at a blank screen, you have this great idea for a program, but you have absolutely no clue where to even begin. Well, today we're going to pull back the curtain on that crucial first step. And here's a secret. It has nothing to do with writing code. It's all about the thinking that has to happen before you ever type a single line. Right. This is the million-dollar question, isn't it? It can feel completely overwhelming, like you're supposed to just conjure up a masterpiece out of thin air. But the truth is, professional programmers almost never, and I mean never, try to solve the whole giant problem all at once. So here's our roadmap for today. First, we're going to face what I like to call the wall of complexity. Then I'll show you two really powerful tools for tearing that wall down. Once we have those, we can build a super clear game plan, and then we'll talk about why this way of thinking is so much bigger than just coding. Okay, to make this all concrete, let's use a simple example. We're going to build a guess the number game. Sounds pretty easy, right? But if you try to picture the whole thing, every single piece of it, all at once, well, it can start to feel like a big, complicated wall you just can't get over. And this right here is the most important mindset shift. We are not going to try to build the whole thing in one shot. That's the trap. The very first thing a programmer learns is to intentionally, deliberately avoid tackling the entire problem from the get-go. Instead, there's a better way. So what is this better way? Well, it brings us to our very first tool for smashing through that wall of complexity. It's a concept from computer science called decomposition. Now, decomposition is really just a fancy word for something pretty simple. It's the act of taking one big, scary problem and just breaking it up into a bunch of smaller, bite-sized pieces. So instead of trying to solve this one huge thing, you just focus on solving one tiny part at a time. So how does that actually work for our game? Well, we can decompose that big challenge into these 4 much simpler steps. First, the program has to pick a secret number. Easy enough. Second, it needs to ask the player for a guess. Okay. Third, it needs to give some feedback, too high, too low, or you got it. And fourth, it has to keep that loop going until the player guesses right. And just like that, it's not some big, scary problem anymore, is it? It's just a checklist. So why do we do this? What's the point? Well, it lets you focus on one single piece of the puzzle at a time. You can perfect that one part, make sure it works, and then move on. It makes finding and fixing mistakes way, way easier. And honestly, it helps you build confidence with every little step you complete. Okay, so we've broken our problem into smaller pieces. Awesome. But now, how do we actually tackle one of those little pieces without getting distracted by everything else? Well, that requires our second tool. This one is all about focus, and it's called abstraction. Abstraction is basically the art of ignoring things on purpose. Seriously, it means you look at a problem and decide what information is absolutely essential to solve it, and then you deliberately ignore all the other noise. It's about finding the signal. And this slide shows it perfectly. For our game to work, what data do we absolutely need? Really, it's just 2 things. The secret number, let's call that target, and the user's guess, we'll call that guess. That's it. Do we need to know the user's name? Nah. How long it takes them to guess? Nope. All of that is just noise we can safely ignore. That's abstraction in action. So let's put our 2 new tools together. We've got our broken down steps from decomposition, and we've got our focused data from abstraction. When you combine them, you get something really powerful, a crystal clear game plan. Just look at this. This is where it all clicks. On the left, you've got our checklist of things the program has to do. And on the right, the exact data we need for each step. To pick a number, we just need to create the target. To ask for a guess, we need a place to store the guess. To give feedback, we need to compare target and guess. See? This simple table is basically a blueprint for our code. It turns that big, fuzzy, complex problem into a simple, logical structure. So why are we spending all this time on this? Look, this isn't really about coding a simple game. This is a problem-solving framework, a way of thinking that you can use for pretty much anything. So let's just quickly recap the 2 big ideas. First, you've got decomposition. That's your tool for turning a massive, scary problem into a simple, manageable checklist. And second, you've got abstraction. That's your tool for focusing only on what you need to check off each item on that list. And really, that's the whole point right there. The most important work you'll do often happens away from the keyboard. These 2 tools, decomposition and abstraction, are what let you wrestle a huge challenge into something you can actually manage.
They give you a clear path forward before you even think about code.
So I'll leave you with this to think about. What's a big, complex problem in your life right now? It could be a project at work, an assignment for school, anything. How could you use these ideas? How could you break it down into smaller, simpler steps and then focus only on what's absolutely essential to take that very next step?